we are asked to solve for the resultant force of vector C and D. So if we look at this picture, we can see it's a hook. And you can imagine two ropes pulling on it in two different directions. And the question is, what is the resultant force? With these two forces being pulled on it, what is the total, or the result, direction of this hook being pulled? And how much is that force? So before we start calculating, let's go ahead and make a guesstimate. So we've got, vector C first. We'll start with that. And it's going up, we'll say 300. And it's 30 degrees off the y-axis. And combine it with it, we got vector D. So I'll do this tip-to-tip method. I'm going to make sure I make vector D a little bit longer than vector C. And I forgot to label this vector C, by the way. So yeah, this is vector C, and then this one over here is vector D. And vector D is 400. And it's 25 degrees off the x-axis. So when we combine these two, well, what do we get? Well, we get a resultant force that's ultimately going this way. We can call this resultant force, or RF. This will be the general direction. Or at least this is our guesstimate of the general direction of the resultant force. And so I noticed a couple things. One, I noticed that it's going up and to the right. Two, I noticed that it's going more right than up. So more right, more right. And then three, well, if we look at it, we can draw an x-axis for this to come off of. And we can say that this angle, theta, whatever the angle of RF is, well, I don't know what it is, but if we look here, then this whole thing would be 60, because 30 plus 60 is 90. So from vector C to the x-axis would be 60. So I know that this has to be much smaller than 60 degrees. So our angle, theta, is going to be less than 60 degrees. And so just looking at this logically, if I get an answer that varies from this, then I very easily could be wrong, and I might want to double check my work. And that's the point of making a guesstimate. But from there, let's go ahead and start solving. So let's start with vector C. So we redraw vector C, and we set it equal to, well, it's still 300. That's going to be our hypotenuse. Let me go ahead and move this a little bit more to the left so I have more room to work over here. And we can first off see that C has a y component and an x component. So we can say C of y. We don't know what that is yet. And we also C of x. And we just know that's how far to the right and how far up it goes. And we also know that it's 30 degrees off the vertical axis. So to solve for these components, I'm going to turn it into a triangle. I'm going to translate C of x up here, sort of as this dotted line. And with that in place, I have a simple triangle to solve with. And so to solve for the component C of x, well, what do we need to do? We need to realize, well, it's the opposite of our angle that we know. 30 degrees, the opposite, and then the hypotenuse is 300. So we could rewrite this as the sine, since it's opposite, the sine of our 30. Well, it's equal to opposite of our hypotenuse, so the opposite is still C of x, and the hypotenuse, well, is 300. So we can rewrite this, and we can solve for C of x. We can say that's equal to, and to solve, we'll just pull out our handy-dandy calculator. We'll type it in. We'll say, well, it's going to be 300 times the sine of 30. So we type that in, and we hit enter, and we get C of x equals 150. And if you look, well, it's going to the right. So now that we know our x component, we can start finding our y component of vector C. Well, to do that, we got to look at what part of the triangle it is. Well, C of y is adjacent to the angle we know. And then this is still the hypotenuse, so we'd say adjacent over hypotenuse. That's cosine. Cosine of our angle, 30. Well, that's equal to adjacent over hypotenuse, where the adjacent is C of y. And the hypotenuse is still 300. Put 300 on bottom. And we can write this to solve for C of y. We can say C of y, well, that's equal to, we got to type it in our calculator, we say 300 times the cosine of 30 this time. So instead of the sine, we do the cosine times the cosine of 30. And we get 259.8. 259.8. And we look, well, the y component is going up, so this is in the upward direction. So now that we know our x and y components of vector C, we can move on to vector D, which has a magnitude of 400 and a direction of 25 degrees down from the x-axis. So we draw our little x-axis here. We add our 25 degrees. And I don't know what I'm doing. We don't want to do that yet because we need to establish our x and y components. Well, our x component is here. I'm sorry, I'm losing my mind in my old age. This is d of x. And then, of course, we've got d of y going down as far as vector d is. And d of x will substitute as our x, or our vertical, or horizontal axes, or x-axes, and that's 25 degrees as well. And to solve for this, what we need is to move our d of y over to make this look like a triangle. So we're just redrawing d of y to make this resemble a triangle. And since it acts like a triangle, we know we can do that. So then we can start solving. So let's start with d of x. So d of x, to solve for it, we need to look at where it is in the triangle. Well, it is adjacent. So this is the cosine this time. And now I want to stop to point something out. Last time the y component was the cosine. This time it was the x. It's not whether or not it's x or y. It's where it is in the triangle. In this case, d of x is adjacent. In this case, c of y was adjacent. So that's important to note. But we say the cosine of what? Well, the angle is 25. We set that equal to adjacent over hypotenuse. Well, the adjacent is still d of x. And the hypotenuse is, in this case, well, it's 400. So to solve for it, well, what do? We say d of x equals what? Well, it equals, we got to type it in our calculator. Well, it's going to be 400 times the cosine of 25. Well, 400 times the cosine of 25. What is that? Well, it's 362.5. So we write 362.5. And if we notice, it's going to the right. And so from there, we can solve for our last vector, or our last component vector. And that's d of y. And we look, well, that's the opposite to our angle. So that's sine of our angle 25. Which equals, well, d of y is our opposite. And our hypotenuse is still 400. And so to solve for this, well, we convert it. We say d of y in this case. Let's pull out our calculator to figure it out. And we say, well, this time it's 400 times the sine of 25. 400 times the sine of 25. And we get 169. So 169.04, so we'll just say 169. And it's going, well, downward. And that's important to note. So with all this in mind, what are our resultant force components? So what is our resultant force in the x direction? Well, the first x component is 150, and it's going to the right. And the second one is 362.5, which is also going to the right. So they just add up, and they both end up going to the right in the end. And these two add up to a total component in the x direction of 512.5. And what about our component of our resultant force in the y direction? Well, we got c of y, which is going up, which is 259.8. Then if you look, we've got 169 going down, so we're going to subtract 169 from it to get our total vector in the y direction. So it goes up, then down. And we get a total component in the y direction of 90.8, and it's going up. And then, of course, this one's also going to the right. So let's see what that looks like. Well, we got our RFY of about 90.8 going up. And then we've got our component in the x direction, which would be way bigger, over 5 times bigger. And so let's look and see what our resultant force is. Well, it's going to go as up as RFY, and it's going to go as far to the right as RFX. And you can see we already went up and to the right, and we went more up than right. And so we've already met 2 of our 3 guesstimates. And we can go ahead and find out if we've met the last one and find the magnitude out while we're at it. So equals question mark. And then we'll label our angle as well, which we don't know. We'll call it theta. And we'll say we don't know that as well. We'll say question mark. Let me go ahead and separate this so we have some room to work for our end. But the end is very simple. First thing, we just redraw RFY here as a dotted line, just sort of to make it a triangle. And to find our magnitude, it's as simple as a squared plus b squared equals c squared. Well, we can find we can find out what c equals by taking the square root of both, and the squares cancel out on the right. And so I can rewrite this equation as RF, or C, RF equals the square root of a squared plus b squared. Well, I'll call my x component a, so 512.5, plus b squared, which we'll call our y component, which is 90.8 squared. And we type this into our calculator. We get it out and we say, well, what's the square root of 512.5 squared plus 90.8 squared? And we get a magnitude of 520.5. So our resultant force magnitude is 520.5 pounds. And to solve for an angle, we're going to take the inverse of one of our three triangle proportions, and it's sine, cosine, and tangent. Well, this time we know the adjacent and the opposite, so that's tangent. So inverse tangent of opposite to our angle, which is our y component, or 90.8, divided by or over our adjacent, which is 512.5. And I'm just now realizing that I had originally written this in purple, so I'll write it in purple here too, equals, and then we just got to plug it into our handy-dandy calculators. We just say, well, what's the inverse tangent of our x and y components? And it's 90.8 first. So we delete that and we say 90.8 divided by 512.5. And we get an angle of about 10.04, or just 10 degrees off the positive x-axis.